All right, everyone, we have to solve equations in this chapter, in this section. Suppose you have one that looks like this. It's a very basic one. Cosine of x equals a half. So basically you want all of the values of x for which cosine equals a half. Now this is the graph of the cosine. Here x equals, y equals a half. And you want to solve for all of the x values for which the y value is 1/2. So here's 1 point, x equals pi over 3, x equals 5 pi over 3, x equals, this point and that point, so they repeat every single 2 pi. So you have 5 pi over 3 here, which repeats after 2 pi. You have pi over 3, which repeats after 2 pi, and so on. That's the point of these periodic functions. So here's our first equation. And we're going to use a lot of algebraic properties to solve this. So first I'm going to subtract 2 sine x from both sides. And what we get here is 2 sine x equals root 2. So sine x is equal to root 2 over 2. Now I want the values for which the sine of x is equal to positive root 2 over 2. Remember, sine of x is positive in the first and the second quadrants. Now sine of x has a value of root 2 over 2 at the 45 degrees, which is the pi over 4s, so anything divided by 4. Here we have pi over 4. Here the next one is 3 pi over 4. So x is pi over 4 and 3 pi over 4, except it repeats every 2 pi, so plus 2 pi n. Senora just walked in. All right, so this next one is a cotangent. We're going to subtract a 4. And we get that it equals 3 dividing by 3 cotangent squared x equals 1. Take a square root of both sides. Cotangent of x is now plus or minus 1. We know that the cotangents are equal to 1 again at the 45s or the pi over 4s. And here, since we're taking the plus 1s and the minus 1s, it's going to include all 4 quadrants. So I have pi over 4 in this quadrant and 3 pi over 4 in this quadrant where it's negative. Tangent repeats every pi, so it's going to be plus pi n and plus pi n. For the next one, we'd like to solve only over the interval 0 to 2 pi. So I'm going to take the root 3 sine x to this side. Equals 0. Notice you can factor out a sine x. Now at this point you solve it just like you would any equation that you factored. Basically sine of x equals 0 independently, and 2 cosine x minus root 3 equals 0. Sine of x is 0 when x is 0 and pi. Here 2 cosine x equals root 3, so cosine x equals root 3 over 2. Cosine is positive in these 2 quadrants. So x is pi over 6, 11 pi over 6. The final answer is all of these x's in order, so 0 pi over 6, pi, 11 pi over 6. And because we're only going from 0 to 2 pi, we stop right there. All right, here too, we're going to take the root 2 to the other side. So we get 4 cosine squared x plus 2 cosine x minus 2 root 2 cosine x minus root 2. And if you notice, we can factor this by grouping. Split it down the middle there. Here we can factor out a 2 cosine x. And we get 2 cosine x plus 1 minus root 2. And you get 2 cosine x plus 1. So factoring out that common term, I'm left with 2 cosine x minus root 2 equals 0. Same thing as before. Here, cosine x is equal to negative half. And here, cosine x is equal to root 2 over 2. In the first case, x is 2 pi over 3 and 4 pi over 3. So these are the x's where cosine is equal to negative half in this quadrant and in this quadrant. And where cosine equals root 2 over 2, these are the 45s in the positive quadrants, here and here. That's x equals pi over 4 and 7 pi over 4. So in order, that's pi over 4, 2 pi over 3, 7 pi over 4, 4 pi over 3. Okay, this is an application problem. A baseball leaves a bat with an initial speed of 30 meters per second and clears a fence 90.5 meters away. So we're given the initial velocity v0 and the distance. The height of the fence is the same height as the initial height of the batted ball. If the distance the ball traveled is given by this, 9.8 is meters per second squared, find the interval of the possible launch angles. All right, so let's see what we have. We're given that d is 90.5 meters, v0 30 meters per second, and we have an equation here for d, which is v0 squared sine 2 theta over 9.8. Since this is an expression for d, and we know that d is 90.5, we can set them equal to each other. And now all I have to do is solve this one. So I have that when I multiply by 9.8, this is 886.9 equals v0 squared is 30 squared sine 2 theta. So sine 2 theta is 886.9 over 900. Now, if I want the angle, 2 theta is inverse sine of 886.9 over 900. And what we're asked here is for the interval of the possible angle. That means we want some sort of a range. What I have here is an inverse sine function. Recall from the last chapter that the range for inverse sine of x was negative pi over 2 to pi over 2. But since we're dealing with degrees, then it's negative 90 to 90. Since I have 2 theta, then the range becomes negative 180 to 180 degrees. All right. What I want to do now is 2 theta. So this is the interval where I want my answers to be. It can't fall out of that interval. Let's continue with the problem. And let's take the inverse sine of x. So 2 theta is equal to 80.2 degrees. Now, in this quadrant, or in this limit rather, when we're from negative 180 to 180, we have to go up to 180. So we also take 180 minus 80.2, which is 99.8. So 2 theta is 80.2 or 99.8. And theta is this divided by 2, 40.1 or 49.9. So my interval is from 40.1 to 49.9. Here are some more problems where we have to use trig identities to solve. Here I have a cosine and here I have a sine squared. But remember, with the Pythagorean identity, I can relate sine to cosine. So I leave this as is. I don't have an identity for 1 minus cosine. But here, the sine square will change into 1 minus cosine squared x. I distribute and bring everything to the same side. So 2 cosine squared x minus cosine x minus 1 is equal to 0. This is a quadratic equation in cosine, so I have to solve it by factoring. Two cosine x minus 1, plus 1 here, minus 1 here. So here I get cosine of x equals negative 1/2. Cosine of x equals to 1. Cosine of x equals 1 at x equals 0. And it equals negative 1/2 in the second and third quadrants at x equals 2 pi over 3 and 4 pi over 3. So those are the answers. The last few are similar. I'm going to take the 2 to this side first, then factor. And what I will do is factor by grouping here. I take out a cosecant squared x. So I have cotangent squared x plus 2 minus cotangent squared x plus 2 equals 0. Factor out the common term. Gives me cosecant squared x minus 1 equals 0. Here I have cotangent squared x equals negative 2, but you can't square something and have it equal to a negative number, so I get no information from there. Cosecant squared x equals 1. Cosecant x equals plus or minus 1. So x is pi over 2, 3 pi over 2. All right, so this is a special case, one of my favorites here. We have a secant and a tangent, and we know that they're related with a identity. However, leaving it this way will never get us what we want. So a trick is to get this 1 to this side. So I have secant of x equals tangent of x minus 1. Now, because the identity is in squares, I have to square both sides. So secant squared x equals tangent squared x minus 2 tangent x plus 1. And I'm going to take the secant over to the other side as well. Tangent squared x minus 2 tangent x plus 1 minus secant squared x gives me tangent squared x minus 2 tangent x. And look at this. This is a positive tangent squared x. So what I have now, that's a minus tangent squared x. So what I have now is that these go away. And I have 0 equals negative 2 tangent x. So 0 equals tangent x. And where is tangent of x 0? At x equal to pi. Okay, last problem. We're going to do the same thing. This time I'm going to bring this sine over to this side because I want cosine squared and a positive sine squared x. So I have cosine x minus sine x equals negative 1. I square both sides and I get cosine squared x minus 2 cosine x sine x plus sine squared x equals negative 1. Cosine squared x plus sine squared x is 1 minus 2 cosine x sine x equals negative 1. What I have now is negative 2 cosine x sine x is equal to negative 2. Cosine x sine x is equal to 1. Cosine x is equal to 1. Sine x is equal to 1. Okay, so when we square this, this is actually a positive 1, which means it cancels with this. So here we have that this is 0. So now, cosine of x equals 0, so x is pi over 2, 3 pi over 2. Here, x is 0 and pi. Of the 4 answers, if I plug them into the original equation here, you notice that only the pi and the pi over 2 work. So the answers are pi over 2 and pi.